for the synthetic, in case the numbers get small, or get big, I'm sorry, not small. We want to do that. And number 6 says we're going to use the synthetic process to find what do you get if you put a -5 into that monster right there. Here's what this means. They're not having us divide. They're saying if you put a -5 in there, what would you get? But don't do it the old way. Don't put a -5 in here and punch this all into the calculator. Instead, put it in synthetically. Now, we don't have to change the sign on this one because this is flat out saying, put this in. That's what it's saying. So now, here's the risk. We have to make sure everything's there. If anything's missing, put a 0 in as a placeholder. So 3, 2, 1, 0, everything's there, even the constant. So we'd have a -1, a -2, a 3, and a -1. And you're going to have plenty of time for this test, so just take your time, bring down your leading coefficient. When you're outside the box, you're multiplying by a, so that's going to be a +5. When you're inside the box, you're going to add. Outside the box, multiply by a. Inside the box, add. And like I said, don't be afraid to grab a graphing calculator if the numbers start getting bigger and you're like, oh, I'm uncomfortable doing this by hand. And then -5 and -12, that's going to be 60, and add. And now here's the big deal also, because you're going to miss a point if you can't tell me what the answer is. Do we use the whole thing? Not for this one. What's the answer? 59. That's it, right there. That last number is what you get. Now here's another one that you could check with your graphing calculator. Luke, focus and put making noises. Put the -5 in here, use parentheses for it, just like you would the old-fashioned way, and make sure you get 59. You're going to have plenty of time to do that, so make sure you do it. Number 7, divide synthetically. However, look at the form this time. X minus 2. So what goes here? Just a 2. Yeah, and I heard somebody say a. And that's because we always had that little x minus a format. So that's just going to be 2 this time. So you don't change the sign when it says, put this in, P of blah, blah, blah. But you do change the sign when they do the x minus a. Now, let's see if everything's there. 3, 2, 1, 0. Cool, we're all there. So we need a 1, a -4, a 6, and a -4. Draw your line. Bring down your leading coefficient. Remember, outside the box, multiply by a, then go inside the box. Where you add. Outside the box, multiply by a, go inside the box. Where you add. Outside the box, multiply by a, inside the box, add. Is our answer 0? Not for this one. Did it say find what you get if you put 2 into this function? No. It said divide this by this. So think back. How do we get our answer from that? Remainder constant x squared. That's how we get our answer. So this will be x squared minus 2x plus 2. That's our quotient, our answer, because they told us to divide. So just putting one number in, we're going to get one number back for our answer. It'll be the number that's in that last position. But if they tell us to divide, we have to write that out as a quotient. So, if I remember from yesterday, it's going to make me erase first. And then I can scroll up. It doesn't like me using Microsoft Word with the recording device. It says, I'm picky, I don't like Word. All right, number 8. Again, it's in that section that says synthetically. So, you've got to figure out what should go there. Just 3? Yep. And that a value is here. Is it in order? Everything there. Oh, Oh, that's where people are going to goof. 1x to the fourth, but no x to the third, and no x squared. So slow and careful tomorrow. Slow and careful. Bring down the 1. Do your thing. Didn't work out perfect then. So what are we going to write for an answer? 71. Oh. Exactly. We're going to put our little remainder on there. And this one has an x to the third this time. So we'd have x to the third. I better write it even bigger. I'm not going to put it in a slot because I want everybody to be able to see it in the back. Plus 3x squared plus 9x plus 23 plus 71 over something. What's the something? X minus 3, right? That's what we were dividing by. So that whole monster would be your answer. It told us to divide. It didn't divide nicely. Oh well. Well, give them what we have. What we do. Alrighty. Now for our favorite part, long division. So let me erase this. Scroll up. You're going to have lots of time though. You know, one of the things that really messes with people with long division is just, am I going to have enough time to think through every step? Yes, you will have lots and lots of time. So that is not an issue. Don't rush yourself and things will go nice. And the reason we can't do this one synthetically, and I scrolled it just a little too far, is because it's not what we're dividing by. Our divisor is not x minus a. It's 2x plus 1. So when there's a number in front of here, it's long division time. Now this is another one where if anything we're missing, you probably want to put a 0, whatever it is. You know, if there's no x term, 0x, just to keep things organized. You don't have to, but it does organize all of this. All right, so we're going to start over here with 2x plus 1. You remember what to do. So what do? We're going to need an x squared because what we're worried about is just matching that first term. That's all we're doing. So we're going to have to multiply this by x squared so we can get 2x to the third plus x squared. It did its job. We got our 2x cubed, so this little x squared will line up right up here where the other x squared are. Wouldn't really need the plus up there. I suppose I should take that off so I'm not confusing anybody. Well, then what do? Yeah, so changing the signs and adding usually makes that easier. 2x cubed minus 2x cubed is gone. That's exactly what we wanted to happen. This would give us 8x squared. Then what? Bring down that next term and start over. We're over here with our 2x plus 1. What do we multiply it by? 4x. Because 4x times 2x is 8x squared. Just matching the first term. The rest of it just happens. We don't have any control over the rest of it. Hey, it worked. We've got an 8x squared and an 8x squared, so a positive 4x is going to go right up there above the other x's. All right. Got to change the signs and add. That's now going to be subtraction. That's now going to be subtraction. 8x squared minus 8x squared, brilliant, is gone. 14x minus 4x, that's a 10x. Then what? Bring down the 5. And start over. Oh, green. So what now? 5. That would give us a 10x. gave us a +5. So 5 worked. And what happens when we change the signs and add? Don't expect that to happen on the test maybe more than once. You know, we want to see that you know how to write out the remainders when they happen. But here's our answer right here, this beautiful little quotient. X squared plus 4x plus 5.
So if there is a remainder, just 2r.
Same thing we did before. You're going to do, like if this came out to be a 3 for a remainder, we'd do +3 over 2x plus 1.
The whole thing over 2x.
Yep, whatever nastiness you have left down there. Long division, coming back to you. Doesn't seem so bad anymore, right? At first it's like, oh my gosh, this takes forever to go through. But that's it. It just takes forever. It's not necessarily the most difficult thing we've ever done. It just takes a while. So, let's see what we have left on this little test. This is an interesting problem. Notice it doesn't say find them all. It says use the rational root theorem to list all the possible zeros of that mess right there. How do we do that? The 2? Okay, so what goes into the 2? Oh, 12. That's a lot of numbers. 1, 2, 3. Forgot my little plus or minus. 4, 6, and 12. Now we do have to write them up as separate fractions. So get yourself organized. I think I'm going to go through with the 1 on the top first. So 1 divided by 1 would be 1. 1 divided by 2 is 1/2. 1 divided by 3 is 1/3. 1 divided by 4 is 1/4. 1 divided by 6 is 1/6. And 1 divided by 12 is 1/12. Done with that one. Got that one done. But now I have to go back to 2. So 2 over 1, that's not there yet. 2 over 3, that's not there yet. 2 over 4, that's up there. Got the 1/2 already. It's there. 2 over 6, that reduces to 1/3. That's up there. 2 over 12, that reduces to 1/6. Hey, this is it. Just going to finish up with a comma so it all looks like, hey, it's this one, then this one, then this one. Ta-da! The only math we do is, can we divide?
So basically, the middle number is not important.
There's nothing for us.
So we just find the first and the last ones, and then we find out the possible. This it makes 10 minutes of practice for each number.
Yep.
So there's a 3. There's going to be 3 over 2. And then 1.
Exactly. So you just go through all the combinations you could possibly have of the tops with the bottoms, you know, and get them all out there. But that's it. They're not asking us to find them. They're saying, hey, what would all the possibles be? So there it is. All right, now I'm going to know I need more room for number 11. That looks like a mighty big problem there. So let's see. Find all the zeros of the following function. And like it says, you've got to show work for full credit. So, how many is it supposed to have?
4.
4 of them.
Nailed it.
Alan's got it.
Got it.
All right.
Good job, fellas.
Sorry?
Ah.
We can start that way. That would be a good way to start. Haley says, do we do the same thing that we did above? Absolutely a great place to start. We could say, hey, we've got a 20 here. That's 1, that's 2, that's 4, that's 5, that's 10, and 20 over Now, why is that a good place to start? Because if when we do get to using the graphing calculator, we're not seeing the zeros, we know, hey, we might have to change our window with this one, because we might have to go all the way out to 20 to do that. Now, I don't know that I'm using the graphing calculator yet, but I'm just saying, if we did, we would have that. So, that has 5 terms. Can we factor stuff that has 5 terms? So we do have to use the graphing calculator. That's what we're going to do. So we're going to use the good old GC to figure out, hey, any of this stuff working here, because we're supposed to find all 4 of them. All right, GC, we need x to the 4th plus 3x to the 3rd plus x squared minus 12x minus 20. Try zoom 6. Looks pretty good for negative 2 and 2. Second graph table, I'm going to take a peek at negative 2 and 2. Beautiful. There. 2. So do we write down a sentence that says, just because the graphing calculator told me so?
No.
No. How do we verify those? Synthetic. Verify synthetically. Gonna make sure these work. Synthetic this down to where we can find the last 2 zeros. So is everything there in this one? Anything missing? Okay. 1, 3, 1, negative 12, negative 20. Let's see what we get. Woohoo! For negative 2, right? That's a good one. So do I start over? No, silly Cedar Home. What do I do next? The 2. We're working this down to try to find all of them. Those 2 are golden, but we have to verify them synthetically. We have to, otherwise we can't find the other 2. We've got to get this down and say, okay, now what's left? Let's see, what do we have here? We've got x squared plus 3x plus 5, and I need the zeros. Factorable? 2 numbers that multiply to 5 and add to 3? No, and you know, we didn't see it on the graphing calculator, so it's probably not factorable. So then what do we do? Gotta find the last 2. Quadratic formula. This is a quadratic formula. A equals 1, B equals 3, and C equals 5. X equals negative B plus or minus the square root of x equals negative B plus or minus the square root. 2a. There we go. All right, so let's put the numbers in and see if we need to simplify. X equals negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 1 times 5. That's an ugly 5. All over 2 times 1, which is 2. Negative 3 plus or minus, oh, looking a little ugly under there. Negative 11. Over 2. Can't leave square root of negative 11. Let me write that. I square roots of 11. So negative 3 plus or minus I square roots of 11 over 2. And then one last check. Can that be simplified? No, we got a negative 3, an I, and a 2. Nothing else we can do with that. So answers for our line. Negative 2. 2, negative 3 plus or minus I square roots of 11 over 2. Did we get all 4? Yes. Remember the quadratic formula always gives us 2 answers. So negative 2 and 2, 1, 2 answers, 2 more from the quadratic formula. Look at all that beautiful math. Woohoo! Woo. Just write answers down, you get nothing. You get nothing. Have to see that synthetic working it down, have to see your quadratic formula, and getting the rest of that in there. But that's a beautiful problem, Mallory. Then really what you can do, Mallory, is just take this off, because dividing by 1 is not going to do anything to those. And this is a help. Like I said, if we couldn't see the zeros, we would know, oops, our window might have to go out a little higher so that we could see that last one. It's not necessarily with this one. This is a 1x to the 4th. Remember, it's all the factors of this over all the factors of this. So we might get lucky, but you know, there might be a 2 in front or something like that. Alrighty, let me erase and scoot. Maybe I can scoot from this side. Where are you, Mousy? There's Mousy. Oh no. Words. That's all the farther it's going to let me go. The product of 3 consecutive integers is 1,716. Write the polynomial equation in factored form and solve to find the numbers. Verify your answers synthetically. Wait a minute. Madison just asked for one of these right before we was practicing. 3 consecutive integers. First one's x. What are the other 2? X plus 1 and x plus 2. That's what they are. Mess around, pay attention. Product. What does product mean? Lucas, that means you. You too, Evan.
Yeah, Evan. Yeah, Evan. Calm down, Evan.
Product. What does product mean? Multiply. Do we know what that's supposed to come out to be? 1716. How do we multiply that? So do FOIL first. Then what? Distribute the x. Are we trying to solve it? Solving means find the zeros, right? Gotta have a 0 over here. X cubed plus 3x squared plus 2x minus 1716 equals 0. Haley, technically you were not wrong, because what you could do is you could use this as y sub 1 and you could use this as y sub 2 and you could find the intersection. But the way that we've been doing this the whole time is get a 0 on one side. Now, we hope we didn't mess up when we did all our multiplication. We hope we see a nice number. Come on, calculator. X to the 3rd plus 3x squared plus 2x minus 1716.
Yeah.
Oh, man.
Uh-oh.
Am I guaranteed my numbers for this are between 0 and 10? There's no guarantee.
Yeah.
Window. Let's try up to 20 maybe. Maybe we'll see it. Second table, we know it's bigger than 10. Doesn't look like it's much bigger than 10. Oh, there it is. It's 11. So GC told us the first number is 11. So what are the other 2 numbers? 12 and 14. So here's our answers, but read through the problem. Write the polynomial equation in factored form. That was right here. And solve to find the numbers. That was right here. But what if we punched it in wrong and we just got it? What if our wrong polynomial gave us that fabulous little 11, but the 11 isn't right? So we are going to verify that 11 synthetically. We're going to make sure that works. So we go back up here and say, well, what's it supposed to work in? Well, the same one we had 0 for. That's what it's supposed to work in. 3, 2, 1, 0, they're all there. 1, 3, 2, and negative 17, 16. Might want a calculator for this one. Bring her down and multiply. Add. Unless you know your little cheater rule for 11s. 154 plus 2 is 156, and this had better be 1,716 or we're in trouble. Aha! Beautiful. So not only did we write it, find the solutions, but we verified it synthetically. And the last thing you could do would, of course, be say, gosh, I wonder what 11 times 12 times 13 is. It better be 1,716 or you did something wrong. Ta-da! Not at all. Was that the last one? Couldn't be. That was too easy, right?
Yeah.
Too easy. All right, so you have your little review assignment from yesterday. That's what you need to work on for the rest of our time together. And go over that practice test a couple times. We talked about this before. What you can do is you could take a piece of paper and cover up the answers that we did together in class and then try to recreate it on your own. But make sure you're doing the review assignment as well, so you've got some practice with the other types of problems you're going to see.